Hello, welcome back to Factoring Videos. In this video, we are going to talk about special types of factoring and review some factoring. Let's get started with the difference of two squares. The difference of two squares, difference means subtraction. Two squares means the first term is a perfect square and the second term is a perfect square. If that is the pattern that you have, then the expression will factor into a minus b and a plus b. Note that the sum of two squares is prime. It will not factor. And if you don't believe me, you can try it, and if you multiply it back together, you will not get the original problem. Take a look at number 1. X squared minus 9. X squared means x times x. 9 is a perfect square of 3 times 3. It is a difference, so it will follow the pattern x minus 3, x plus 3. Number 2. X squared is a perfect square, x times x. 121 is a perfect square, 11 times 11. But it is a sum. Therefore, this is prime. It will not factor. Number 3, we have two terms. The first term is a perfect square, 2x times 2x. 81 is 9 times 9. It is a difference. Therefore, it'll factor 2x minus 9, 2x plus 9. Number 4, y squared is y times y. 9x squared is 3x times 3x. It is a minus. It is a difference of perfect squares. So we know that we'll factor into y minus 3x and y plus 3x. Number 5, difference of perfect squares. 100 is a perfect square. 10y times 10y. 1 is a perfect square. And then we know that one parenthesis has to be a minus and one has to be a plus. Number 6. 64 is 8 times 8. So we have 8 minus y and 8 plus y. And number 6 is unique in that if we decided to rewrite this, negative y squared plus 64, our leading coefficient is negative. So if we factor out a negative 1, now we have y squared minus 64, which is a difference of perfect squares. So that could also be an answer. Again, that particular problem is unique and both answers are correct. Next, let's take a look at perfect square trinomials. The techniques that you have already learned can be applied to these, but using the perfect square trinomial pattern could possibly save you some work. But you do not have to use this pattern because the same techniques that you've already learned will work. And this is what I mean. For number 1, we could find the factors of 9 that add to negative 6. And that's negative 3 and negative 3. So we could write our factors down. X minus 3 times x minus 3. Or we could write it as x minus 3 squared. But let's take a look at the pattern. The pattern is, if the first number is a perfect square, which it is, x times x, And the last number is a perfect square, which it is, 3 times 3. Is the middle 2 times a times b, where a is x and b is 3. And sure enough, 2 times 3 is 6, and the middle term is 6x. The signs, you'll notice, if the middle term is a minus, then both of your factors will be minus. So we could use the pattern here, and we can conclude that this would be x minus 3 times x minus 3, or x minus 3 squared. And again, you can look for the pattern and use it, or you can factor using the techniques that you already know. I'm going to use the perfect square trinomial pattern here so that you can see how you can use it as you practice all of your factor problems. So x squared is x times x, 121 is 11 times 11. Ask yourself, is the middle term 2 times x times 11? And indeed it is. Everything is positive. So your factors are x plus 11 and x plus 11, or just x plus 11 squared. Number 3, 4x squared is a perfect square, 2x times 2x. 1 is a perfect square, 1 times 1. Is the middle 2 times 2x times 1? And indeed it is. It is a minus. So we know this will factor into 2x minus 1 squared. Number 4, y times y, 4 times 4. 8y is 2y times 4. It's a positive, so our factors are y plus 4 squared. Number 5, this is where this pattern can really help you, because the first 4, if you are using the AC method to factor, it wouldn't be much different. But for number 5, using the perfect square trinomial pattern could really save some time, possibly. So 25 is 5 times 5. Y squared is y times y. 4 is 2 times 2. And I can see that 20y is a product of 2 times 5y times 2. It is a negative. So I know this is going to factor into 5y minus 2 squared. Number 6, 8x times 8x, y times y. The middle is 2 times 8x times y. We know this is 2 times 8x times y. This is a positive. So our factors are 8x plus y, and 8x plus y are just 8x plus y squared. So there are some practice problems on perfect square trinomials. Now let's take a look at sums of cubes and difference of cubes. You're going to use this pattern when you have 2 terms, and the first and the second term are both perfect cubes. The pattern for a sum of perfect cubes is that the first factor is the cubed root of a and b. This s right here means same. You're going to give this factor the same sign that is in the expression. The next factor is a squared minus ab plus b squared. The first factor has the same sign. The next sign is the opposite of that sign. The last sign is always positive. So the SOAP over here stands for same, opposite, always positive. And it's just going to help you remember the signs. So if you have a difference, your first factor is a minus, then a plus, and then a plus for your factors of your signs. I think this is a little easier if we just try some practice problems. Number 1, x cubed is a perfect cube. So I'm going to write a is equal to x because x times x times x is x cubed. 27 is a perfect cube because it is 3 times 3 times 3. So all we need to do now is look at our x and our 3. Our first parenthesis, or our first factor, is going to be x minus 3, the same sign that is in the problem. The next factor is a squared. So x times x is x squared. The opposite sign. Then a times b, or x times 3, which is 3x. And then b times b, which would be 9. It's factored. Beautiful. Number 2, we can factor a sum of perfect cubes. A is equal to x, b is equal to 4. Be careful with 64. 64 is both a perfect square, 8 times 8. It is also a perfect cube, 4 times 4 times 4. We have everything we need. First factor is going to be x plus 4, same sign that's in the problem. A squared would be x squared. A times b would be 4x. 4 times 4 is 16. Your signs are same, opposite, always positive. It is factored. Let's move on. Number 3, 2 terms. Each term is a perfect cube. So a is equal to x, b is equal to 2. Your first factor right there, x minus 2. And then you're going to multiply x times x, 2 times x, 2 times 2, same, opposite, always positive. Number 4, 8x cubed. 8x cubed is a perfect cube. A is equal to 2x. B is equal to y. All we need to do is look right here at our 2x and our y, and we will have both factors. 2x minus y. 2x times 2x is 4x squared. 2x times y is 2xy. And y times y is y squared. Same, opposite, always positive. Number 5, a is equal to 3x. B is equal to 5. 5 times 5 times 5 is 125. Our first factor is 3x plus 5. Our second factor is 3x times 3x, 9x squared. 3x times 5, 15x. 5 times 5, 25. Same, opposite, always positive. And finally, number 6. 8x cubed is 2x times 2x times 2x. 125, we just did on number 5, is a perfect cube. 5 times 5 times 5. Our first factor, 2x plus 5. The next factor, 2x times 2x. 4x squared. 2x times 5. And 5 times 5. Same, opposite, always positive. And we have mastered sum and difference of perfect cubes. Way to go. All right, let's summarize what we've done so far in this video series on factoring. How do you know which type of factoring is necessary for a polynomial? Number 1, is there a common factor for all terms of the polynomial? If yes, you want to be sure that you always factor out the greatest common factor first. Number 2, count the number of terms in the polynomial. When you have 4 terms, you will factor by grouping. When you have 3 terms, I highly recommend the AC method, which also includes the slide and divide. I would also look for perfect square trinomial pattern. If you have just 2 terms, you could have a difference of squares, has to be a difference, or it could be a sum or difference of perfect cubes. And then finally, look at your factors. Make sure that your factors are all prime, that they don't have any common factors. So here are 12 practice problems. So please stop the video, work on these 12, and then when you have them completed, continue on with the video to check your work. Welcome back. Here we go. Let's go through the answers. Number 1, a difference of perfect squares. Number 2, a difference of perfect squares again. Number 3, you guessed it, a difference of perfect squares. Number 4, greatest common factor. 3 and 48 both share a common factor of 3. They both share a variable x. Take out the one with the smallest exponent. You're not finished factoring because look, x squared minus 16 is the difference of perfect squares. So we get to factor the greatest common factor, and then we factor some more. Number 5, the factors of 9 that add to 6. Or you could have also approached this from a perfect square trinomial approach. Your answer should be x plus 3 squared. You can write it out as 2 factors or squared. Number 6. You could approach this from the factors of 36 equals -12. Or you could have realized that 36 is a perfect square, 6 and 6, 2 times 6 is 12, and use the pattern to find your factors. Number 7. I see that the first term is a perfect square, 2x times 2x. 1 is a perfect square, 1 times 1. -4x is 2 times 2x times 1. So I'm going to use the pattern on this one. 2x minus 1, 2x minus 1, or 2x minus 1 squared. There's more than one way to work out a math problem. Just make sure that you have the same factors as I do. Number 8. I'm definitely going to see if this is going to follow a perfect square trinomial pattern. So I have 3x times 3x, 5 times 5. 30x is 2 times 3 times 5. So this is going to factor into 3x plus 5 squared. Number 9, 5, 40, and 80 have a greatest common factor, 5. So I'm going to factor out the greatest common factor. I'm going to factor some more. I need the factors of 16 that add to -8. So let's go -4 and -4. Or we can write it as 5 times x minus 4 squared. All right, here we go. Number 10. X squared is x times x. 64 is 8 times 8. But whoa, hold on. It's a plus. So this is a sum of perfect squares. It is prime. Number 11. 2 terms. 8x cubed. This is a sum of perfect cubes. First factor is 2x plus 1, same sign that is in the problem. Hope your answer matches mine. And number 12 is the difference of perfect squares. A is equal to 8, B is equal to 2. Our first factor is x minus 2, A times A times B times B, same, opposite, always positive. And there we have it. I look forward to seeing everybody next time. Bye for now.